By the way, yeah, Fractal Fox works on EEG classification, which is that thing where they measure the electricity in what's the proper definition of it? By the way, they do something with electricity that is going on in your brain, and yeah, he's into neurofeedback research and does software for non-invasive computer vision-based wildlife identification, which is a very cool thing, I believe. Yeah, this was your biography in a couple of sentences, made very, very badly. Anyway, yeah, so...
Oh, hello? Ah, perfect, okay.
Yeah, so please give him a big round of applause for his talk.
Yeah, thank you. Thank you for joining this session. Yeah, I put some crappy description of what I'm actually doing. So the wildlife thing is actually a separate project. So what I'm basically doing EEG, BCI research, and yeah, and so this is what I actually want to talk about, because recently I felt like I was waking up in the future. I mean, because we have all this new technology right now happening. Like rejuvenating cells, what is it, open AI, like driving cars, self-driving cars, everything. Just like it's tangible almost. And so now we have brain-computer interfaces, and also made affordable, and to the point where you can say it becomes reliable actually. And yeah, so, but of course always with new technology, there might be some people who want to misuse it, and so like there's a great responsibility coming. And so I know this place here, I find probably the most progressive people around technology. And that's why I want to share this update on the BCI progress that we did already last year with MetaMind and Masahiro. And yeah, all right, so let's get started. So yeah, this is basically where we want to head. Okay, so, but yeah, I know a lot of people probably know something about, or know maybe a lot about PCI, but I have to be fair and just give a little introduction first. So for the people who don't know. And yeah, then I will talk, of course, about the challenges or things that actually are going to be relevant. And yeah, I'll also give a view over the consumer devices that are currently available and all the open source approaches right now. And okay, so yeah, here we go. Bear with me, this is just the basics right now. I'll try to keep it short. So what is EEG? EEG is basically, it's electroencephalography. You have this beautiful plot here. This is actually what we can measure on the surface of the head. That's what Hans Berger in the 20s found out. You can do it also with humans. So he puts these electrodes and somebody's closing the eyes, and then he opens it, and you have a totally different pattern of brainwaves. And so yeah, it's a non-invasive brain imaging method, and it's probably yeah, one of the best known, so to say. And okay, and so yeah, this is like maybe a typical mount. So you have like electrodes, and you place them in a certain areas that correlate, of course, to brain activity and different areas of the brain, and then you get this signal. And so basically, you can interpret it as how many times a second does a wave go up and down, and then you can do an analysis on this. You have the frequency analysis, for instance. That's something that's being done quite often, actually. And so what else can you do? You can unmix the signal, and then you, for instance, you can determine the arousal state, like, so how awake are you? Are you almost falling asleep, or did you just have like a bunch of coffee? And yeah, like this kind of scale we can see here. This is the typical scale. Of course, there's also different activity. And yeah, so basically we can do so much more actually with this, in combination also with machine learning, of course. And So, but let's just have a slight definition here, just to so you can see like the basic difference or how we can operate actually a brain-computer interface. So like this is
ha ha. So this was the end of it? No, joking.
okay. Sorry. Hello? Ah, okay, all right. Perfect. So yeah, okay, so like three basic, way to differentiate. We have active brain-computer interface where you, for instance, think about your left or right hand, and of course need some training, and then yes, you can directly control the device with thought. That's one approach. Then you have reactive, where you show certain stimulus. That means, so you show something like maybe something visual or something auditory, and you have a certain reaction. And then also you have passive ones. Those are the ones that you probably won't notice much. It's kind of tweaking your user experience. And so you probably won't even notice them. And yeah, so this is like a very basic circuitry of brain-computer interfaces, where you have the user and then you have the electrodes. We do amplification. I mean, this is a very simplified approach right now. Then the filter, AD converter, and then we send it to a software. We do some pre-processing because, of course, we also have a lot of noise in the data. Then we really look for the data that we can use, the feature extraction, and then we have some machine learning algorithm that can run a command based on the interpretation. And okay, so yeah, so as I said, so it really depends on where I put the electrodes, and there's so many possibilities actually here, and this is only a crude map, of course. But yeah, for instance, spelling computer is something very nice, I think. So you just see maybe a screen with with the alphabet, and so the letter you're thinking of, maybe the line is then highlighted, and so we can measure actually. This is then the letter you're thinking of is actually the target stimulus here in this P300 scheme, and then this is like a different reaction. We can really measure this to anything else, like anything that's not the letter you're right now thinking of. And of course, yes, so maybe you saw already also the videos where people can actually control by thought exoskeletons and prosthetics. Yeah, so, and next, something that's also now very popular for, also for the commercial consumer products is the neurofeedback. And so what is basically is you can learn, you can really train your brainwave activity. And so the way it works is we constantly measure actually the brainwave data, then we do the processing, and we have an interpretation. Is this going near to the state of well-being you want to be, maybe? Then we give in this moment we give a reward. So in this, the reward is a sound, and then you say like, oh, okay, that was the sound. This is great, and your brain tries to reproduce this sound. So at the same time, you're changing your brainwave activity. And yeah, okay, here I brought some samples, examples. This is more maybe for clinical and medical use, of course. But yeah. So that's the hacky thing. Of course, you don't have to be sick to use neurofeedback. You can still optimize your brainwave activity. And yeah, and then also for artists, it's a nice thing. It's easier than never to make an interactive installation where you can have an audio-visual feedback. Maybe you can design it. It's just the nuances of your arousal state, and also maybe in combination with somebody you're doing it together with. So it's a whole new, it's a new experience. It's something new that you can really feel. So I tried. I did a similar setup also at a festival, and it was quite interesting with 2 people. and yeah, I can really say it's something special and yeah, worth. Really worth trying. So then neurogaming. So this is basically the gamification of neurofeedback. So also there was the second conference on neurogaming already in San Francisco this year. Okay, and then there's this new approach, not so new approach, but now new approach in consumer. The consumer landscape is to combine EEG or to use TDCS, transcranial direct current stimulation, or transcranial alternating current stimulation, which is basically zapping your brain. The problem is there's not much, there's no long-term studies so far. I mean, people say it's nice. It's like, wow, I feel like I drank a bunch of coffees and I'm so active. Okay, but I don't know. Can you do without? Is it something that lasts? It's not so sure. So yeah, there's some scientists also who say, yeah, you can try it out, but you should be careful, definitely, what you're doing. You should be knowing what you're doing. Okay, so maybe just give a quick overview. The methods, this is not all of them. This is just the ones I found interesting. Here's the P300. That was the one where you respond to a certain stimulus, the target stimulus, and the spell computer, for instance. And there's no learning involved, really. Then we had the steady state, visually evoked potentials. This is where you can, for instance, have a blinking light in a certain frequency, and you will have, you can actually read this in the occipital, so in your visual cortex, you would have a certain response to this. And so this is also maybe an example of a reactive BCI. Then we have slow cortical potentials, SMR, motor imagery. This is again the active one, and yeah, this is yeah, also quite a good one. So okay, but yeah, let's just have a quick look at the consumer devices right now. And first, okay, we should clarify what are we looking for. What would be the criteria to say this is a good device or this is a bad device? So I just thought of a few points. Of course, depending on what you want to do, they might be different. But of course, the first thing is cost. I mean, so you maybe don't want to waste $50,000 and then say, oh wow, okay, I can make a robot go in a circle and the other one, and oh wow, nice, $50,000. So okay, maybe a little less, and but what's really important is the specificity and the reliability. So you don't want to buy some stuff and see, oh, it's just it's noise in the data. So like, I mean, you should ask yourself, is really brainwave coming out of this thing? So I'm not going to point the finger at any commercial product right now because I only have 10. But so like, it's really it's really something you want to look at. It's really the essential thing. You want to have clear data, clean data. And okay, so the next thing is the hardware and software degrees of freedom, so to say. This is then more, of course, interesting for hackers, I guess, if you have the chance to change some parts, change electrodes, and of course, what's also essential then to have the raw data access, and then ergonomics. I mean, you don't want to waste 10 minutes trying to set up your EEG BCI device. Not maybe even 30 seconds. That really sucks because like every time you want to try it at night, at some point during the day, and then you fiddle around the whole time, and then it's like it's a turnoff. You don't want to deal with this the whole time. Well, of course, yeah, depending on what you want to do. So and then one important thing is the product safety and security. So safety, I would say, of course, you don't get you don't get a shock from the system. There's not a dead circuit or something. And security, I will come to this later. This is also one point. Okay, so just, yeah, I know this is just a few devices I picked. There's no, so to say, yeah, just like the, yeah, right now popular ones, but there are also other ones, of course. If you do some research, the NeuroSky Mindwave is kind of, I think, popular. does a good job and has good connection. I mean, it's easy to mount, and they at least have a hardware DIY guide. It's nice. Then the Emotive I was working with 2 years, but I was kind of the Epoch, and I was kind of annoyed to put this to other people's head actually, because yeah, if those people have a lot of hair, you're really sitting there sometimes 10, 20 minutes, and the guy's asking like, what's happening? I don't know, nothing's really, yeah, am I waiting for something? Yeah, the electrodes, yeah, it's not really working, and yeah, that's also, again, as I said, a turn off. But I'm really, yeah, I'm curious about the inside. I think it's actually just launched, and the Interact Muse also looks like a legit headset. Melon I put here, I couldn't, so they couldn't give me the data sheet really, but it's also very affordable. All right, so, okay, so what is the progress? So if you look at the devices, they all have dry electrodes. That means not like it used to be, you have to put gel to have a good conductivity. It's different now. So like dry electrodes, but the problem is you have to make sure you really you get a higher impedance, and then it's very sensitive to noise. You can really get noise very easily, so you have to think about the design of your circuitry. And of course, yeah, the algorithms get better, and it's something that improves, of course, but if the signal is bad in the beginning, sometimes there's not much you can do, and yeah, then you don't have a working VCI actually. Oh, okay, that was one too fast. Okay, so then let's move on to the open source DIY. So yeah, so of course the time's a little bit too short to go in detail about the hardware setup, but we're gladly going to help you guys. If you come by, we can talk on the details of the hardware implementation really. But yeah, and also I now just picked like a few devices again that projects that either have like a tutorial how to do a device for yourself, or that already offer maybe like a kit or something that you can really start during VCI. Okay, so here just the list. And the OpenEEG project, I think, has been is quite popular. This has been online for a long time on the SourceForge page, and they're doing a really good job. They also have a lot of tutorials there, and and then they say it's like something between $200 and $400 to have to build this device by yourself. But then you also have a company that basically assembled this all in the box, and then also yeah, probably also heard about the openbci.com project. This is where you can really 3D print also the EEG or PCI device, and you have a different approach, also more electrodes, but also like one with 4. And then the openbci.org, the one that comes from MetaMind and Masahiro, and with over 30 years of research. And this is also one, yeah, can be stacked, and the amount of electrodes, and it can be used either with Arduino Uno, or you can use, basically you can exchange also the microcontroller here. Yeah, so but yeah, what is the core difference? Why would you either pick the one or the other? So again, it really depends on what you're planning to do. Is it something you want to do at home, some simple setup, or you want to make research, low budget research, so to say? You want to have holistic recording with a lot of electrodes. So you have to think about that. But so like maybe one core difference is also the AD converter that Masahiro picked for the Brainduino. So you can use it actually better with dry electrodes. So yeah, it's more, it's actually easier to start with it due to the setup. And yeah, okay, just maybe then a few words to the electrodes, because this is the thing that you cannot, I mean, you didn't have with the consumer devices, but like with with hacker devices, you can really just say, okay, I want this or that. Very something that is also in the scientific realm. You have the like a standard is the electrodes, which are like a cup, and then they're basically the material is something like silver, gold, or tin. Then you have big differences, passive and active electrodes. So passive means I have an electrode and then goes maybe over a wire, and then you have the amplification. But on the way, it's a problem that you maybe get some signal noise also because of electromagnetic fields, for instance. The active electrode, on the opposite, is you amplify the signal right after the electrode, and which makes a better contact then and better signal. Okay, and then also something very new, you have bendable electrodes. I saw a publication, I think this is also coming up, so something very ergonomic. Yeah, of course, and also you can hack electrodes. You can just take some silver coins and solder them to a screw and then connect it. Works perfect. Yeah. Okay, and then software. So I only also picked a few. Of course, there's much more, but like OpenVike is one of those that's quite has been there for a long time also. And you have a visual editor, and you have all the machine learning and all the filters there also, and like a lot of tools. And yeah, Brainbase also, unfortunately only for Windows, but then Neuron was also new software. It's not open source, but it's free to use. So yeah, but I would suggest for the beginning, or you have maybe some other toolboxes for MATLAB if you do it like in the research field. But OpenVibe is always a good thing to go, I think, the beginning. And so one important thing I want to talk about is really privacy issues. Maybe still feels like it's in an early stage, but if you think about it, if brain-computer interfaces become more popular, like, you know, used to be like Fitbit maybe or something like that, and now it's, you quantified the body, now you quantified the mind, and becomes popular, then you should ask yourself, what happens with my data, with my brainwave data? Because there's actually some things that you can do with it. And yeah, so let's just take a look at this titles here. So the headlines, brainwave privacy standard is needed to prevent spying on EEG data, scan data. Researchers go on. Okay. Buffin's proposed brainwave privacy standard, EEG data can predict illness, and app makers are storing it in the cloud. I think, wow, that's shit. I don't want that. That's really something I want to prevent. So I think it's a critical time that we should actually get in conversation and discuss this really, because yeah, I don't know where this could be heading. I mean, I'm not overly paranoid, but as you can imagine, there's a lot of things you can really use here, misuse. And yeah, so basically something about health conditions, cognitive performance, and then of course there was also a publication talking about achieving with the consumer device. They found out the PIN code, month of birth, locations where you know, or people you actually know. So all this data can be actually compromised. And yeah, so you have different stages of attack. And of course, what we can do is with the open source community, we can, of course, look if there's something maybe around the device. Maybe we can check out, we can do we encrypt the brainwave data before we send it. But okay, no, it's going to be hard anyways, but we should discuss about it. Yeah, so so again, I would say the privacy standard is really something essential. It's something that should be discussed, and then yeah, so then this is something that where I really want to also. That's why I'm here, also to discuss with you guys if there's some approach that we can make a safer brainwave experience in the future. And yeah, so just come by the Neuro hacking space, and yeah, we can discuss. You can try out the device. We have a lot of devices there from all sorts of all the consumer open source devices we listed are actually there, and yeah, try out, test, and then if you want to hack something, we're glad to help you and answer all your questions. And yeah, again, as I said, so maybe you also have a good input for so we can kind of go on with the privacy of brainwave data. And yeah, and also for the Brain2Eno project, there's going to be a Kickstarter. We want to make it more affordable. Yeah, also if you want to participate, yeah, just come by again. Yeah, but that's basically it. Thank you for listening. Okay. Oh yeah, questions, right?
Yeah, there is already a question from the internet, so please go.
Thank you. First question, do you know of any plans to regulate the whole technology? Devices that send waves and have the capability to, you know, tamper with your brain shouldn't maybe be easily to be allowed?
Yeah, I'm not sure. I mean, the problem is sometimes you, I mean, the consumer market then, so like, okay, I will repeat the question. So is there any way to
Excuse me. Yo, sorry. Shut up.
What?
Okay.
So is there any approach? So I would say the problem is always the disclaimer, like mouse, like very small printed things, and then you're not sure on if you're a consumer of a if you're buying consumer product. So from that point, it's quite hard, I think, to regulate at this point. But yeah, I don't know if there would be like a standard, like a read data standard and a safety standard, then maybe this could be done. But of course, there's so many steps where you can attack this actually. So yeah, it's quite a complicated topic. Okay.
There is a question on the microphone in there.
Oh okay. Yeah, okay. You had the slide at the beginning where you outlined the basic flow of the data when first it was analog, taken from the brain, then changed to dialogue data, or digital, sorry. And there was a filtering process. Before that, my question is there a direct advantage of filtering the data before changing it to digital data? And what sort of filtering is done there? Is it just a bandpass or is there something else?
It actually, so I mean, this was quite simplified graphic because we have also different kind of amplifiers before, or instrumental, but yeah, so it makes sense before you send it further. But yeah, maybe if you have the time, maybe you can come around and we can show you like some detailed schematics actually, and try to explain why this makes sense at this point. But yeah, also, I mean, if you don't want to come by, it's all online. I can show. Yeah. Yeah. Sorry.
To my left.
Hello?
No? Yo, there is a question in there.
Hello? Oh. About the Epoch headset, there was a small bullet point mentioning that it has a raw data hack. Could you please elaborate?
Yeah, I mean, I'm not sure if this. I mean, yeah, I mean, if you look in the search engine, you can. I mean, it's quite easy to find. It's also on GitHub. There's some forks of it, and yeah, it's actually quite easy to use. But yeah,
Okay,
it's possible. Yeah.
Hello. You were talking about also the dangers and the misuse that can be done with it. The dangers and the misuse that can be done with it, with the system. There will be misuse. You know that it will come. Yeah, I mean, it's part of it. So how, as a scientist, do you work with that? You know, on the one hand, you clearly know that it's good and all the good things that come out of it. On the other hand, it's a very, very powerful technique.
I think people should be able to decide by themselves if they want to share their brainwave data or not. And every action I do before this, I want to make sure 100% that it cannot be compromised. I think that would be like maybe some opt-in, if you can say, okay, I'm fine, I put my raw data online in the cloud. They can use it for analysis, for like cloud analysis. Yes, definitely, it's a powerful tool. But yeah, I think it should be opt-in. There should be no compromising before that step.
Do you also believe that it will, sometimes, you know, in our society, we have the brain and the heart, you know, and we separate it. I don't know why, but this happens. Do you think it will lead to us getting brain and the heart closer together again? I mean, sometimes you don't know what you're feeling. You know, you can't describe it. Do you think that that whole technique can help?
Well, I mean, so basically, I mean, how I think about neurofeedback, for instance, is it's like meditation with guidance. So, like all the research also going on with meditation, you know, kind of bring it to the core. What does it really do? How it change your brainwave chemicals really, and in a profound way. And I mean, with this, I mean, what's following this is that you become more aware, of course, of your surroundings. So maybe, in a way, this brings closer together the heart and the mind, so to say. Yeah.
Yeah.
Thank
so
you.
there is a question to the microphone at my right.
Yeah, I think PCI is quite interesting, but since it's an interface, I'm interested in whether there are any methods of inducing brainwaves instead of just measuring them. Imagine a world in which you think of something and you get a Wikipedia article directly in your brain. It would be quite interesting.
Yeah, so like this is the, I mean, there are different approaches right now, non-invasively, but in a way it is invasive. You have the TDCS, I mean, so the problem is you don't have like long-term research on this. You can be your own guinea pig, of course. You can buy the devices and just check it out, what it does. But so like this is, you know, like forcing brainwave activity. The other thing, I mean, I try to explain the neurofeedback is really, it takes some time, but there's like, depending on what protocol you're using, you can regulate also, you can change brainwave activity. And the great thing about it, it stays the way. So it's not like, so like you're really building new bridges in your brain. I mean, the same with TDCS, but it's not forced. And the problem with TDCS also, it's like very unspecific right now, at least. It's like you're firing in every direction and changing something forcefully.
Okay.
Yeah.
Thank you.
There is time for one last question from the Signal Angel.
Thank you. My question from the internet goes along the lines of the last question. Could you elaborate a little bit on the brainwave training part? What's the status? What are the benefits?
Yeah, so I mean, it's used right now, for instance, to like ADD, like attention deficit disorder. It's an alternative to Ritalin. You know, that's like basically it's an amphetamine that they're giving to children, and so it's very harmful for the body. But instead, you can do neurofeedback training actually. So, I mean, of course, you have to do some practice, and maybe you have to do also some follow-up practice. But in the long run, it helps you with the situation in a very good way also, and you don't have to take chemicals.
Yeah, I'm super sorry for you guys, but we're running out of time and I've got to cut it short. So yeah, thanks a lot for the talk.
Yeah, also you can just come by.